Hello science lover. In today's podcast, we are going to discuss about thermodynamics. First, we try to learn some terminologies which are frequently used in thermodynamics, like system. A system is that part of the universe in which we made observations is called as system. Surroundings. All remaining part of the universe other than system is called surroundings. So universe is equal to system plus surroundings. Types of system. The system is classified on the basis of movement of energy and matter inside or outside the system, that is open system, closed system and isolated system. Don't worry, we will explain all of these. First, open system. A system in which exchange of matter and energy between the system and the surrounding take place is called open system. Example, reaction in open beaker. Second, closed system. A system in which exchange of energy between the system and the surroundings take place, but there is no exchange of matter between the system and the surroundings take place. It is called as closed system. Example, reaction in closed conducting vessel of steel. Third, isolated system. A system in which no exchange of matter and energy between the system and surrounding take place is called as isolated system. Example, reaction in isolated vessel like thermos flask. So this is three types of system. The system in which exchange of energy and matter both happen, that's open system. If there is only exchange of energy but there is no exchange of matter, then that's closed system. If there is no exchange of matter or energy, then there it is isolated system. Now we try to learn the states of the system. In chemistry, the state of thermodynamics system is described by the measurable or macroscopic, that is bulk properties of the thermodynamic system. To learn better, if someone asks how we can describe the state of a gas, so to answer to this question is, we describe the state of a gas by getting information about pressure, volume, temperature, amount, etc. of the gas. So these variable, that is P for pressure, V for volume, T for temperature are known as state variable or state function. Now question is, why these variable P, V, T are called state variable or state function? These variables are called as state variable or state functions because their value depends only on the state of the system and do not depend on how they are reached on that point. Now we try to learn internal energy. Sum of all energies, that is chemical, electrical, mechanical, etc. of the system is called internal energy U of the system. Now question is, when internal energy of the system changes? Internal energy of the system changes when heat passes into or heat passes out of the system. Second, work is done on the system or work is done by the system. Matter enters in the system or matters leave the system. So any of these things happen, then internal energy of the system changes. Now we'll try to learn what is work. Work, before learning about effects of work on internal energy, we first understand what is adiabatic system. Adiabatic system is a system which does not allows transfer of heat through its boundary, means heat cannot enters or leaves the system. So adiabatic is a type of system in which transfer of heat through the boundary of the system is not allowed. Work on adiabatic system. If 1 kilojoule mechanical work done, case 1, on this system and 1 kilojoule electrical work done, case 2, on the system, then changes in temperature is same in both cases. So amount of work done on this system produces the same changes of state no matter how this work was done. So delta U is equal to U2 minus U1 is equal to WAD. AD is a symbol for adiabatic, where U is internal energy, U2 is equal to internal energy at state 2, that is final state, U1 is internal energy at state 1, that is initial state, WAD is adiabatic work. Sign of WAD is, if AD is positive, then work is done on the system. If WAD is negative, then work is done by the system. Now we try to learn heat. What is heat? The exchange of energy due to difference in temperature is called heat. If system allows exchange of heat, that is conducting walls of the system, then change in internal energy depends on amount of heat transfer between system and surroundings at constant volume when no work is done. So delta U is equal to Q, where U is equal to internal energy, Q is equal to heat, and sign of Q. Q is positive if heat is transferred from the surroundings of the system. Q is negative if heat is transferred from the systems to the surroundings. So this is a discussion on thermodynamics. We think you like it. If you find it interesting, do subscribe us, follow us, and we will meet you with very interesting topic very soon. Thank you to listening this podcast. This podcast is brought to you by www.chemistrynotesinfo.com. Thank you to listening this podcast.